Hello and welcome everyone. So this is another session on backpropagation or Autograd computational graph implementation, in which we just want to let you know that I have having issues with these missing links actually, and I'm currently working with the layer norm layer, which is which just falls under our forward pass, and the problem is right now. We have implemented this successfully for multi-head attention. In case if I want to show you, if I run this without ln.c, right, and let's see how it works. So here is the report we have. Looks like we need to just do a couple of fixes here. So first of all, let me just remove this swap file ln.c and comment this thing out. Oh man. And go to the file called attention2.c and uncomment this thing. Yeah, like so. And now if I run it, you see this is actually the return result of multi-head attention. And where exactly is the graph report? In case if I just go to attention, and let me just uncomment this for a sec so that you can see what the graph report looks like currently. So this is actually the graph report. We have all these nodes available along with their IDs, along with their parents details, along with their backward functions and gradients. So you see we have this node available which is at 239, which has ID 239, which has parents 8, and the thing that I see, there's not much problem over here. I mean 77 nodes are visited and we don't see any missing links. This is important. So there is no missing link. Every tensor is connected with its backward tensor, right? Whereas if I go here, let me just comment this thing out, ln.c. If I check stuff over here, we have lots of different problems, right? Yeah, that's it. So now if I go to run and if I add ln over here, that is ln.c, and let me just try to run this one more time. So you see we have 13 nodes visited and we have 2 missing links, which is like very important. We have 2 missing links, and if you see we have tensor 246 has null parents at 0. So I think there are 2 tensors. There is some tensor which has 2 parents, and I haven't set them. Right? So yeah, so I haven't set these parents. So now I want to trace out which actually is the tensor where I haven't set these parents, right? So let me just try to debug this. I don't have any clue how am I going to do this, but let's just try to do this and try to understand that's what's going on here. So in case if I come here, then ln. So this is actually forward, and let's see what am I doing here. Okay, so first of all, this is our forward, MHA forward. Let me just comment this out for a second, and this is my X. These are the features. These details are coming from multi-head attention. Let me just comment this out for a sec. Let me just delete this. I don't want to visit this graph, and I just want to see stuff over here. So where is our X? Yeah, so this should not be out now. This should be X instead of out, right? So we're just applying this layer norm function on this newly initialized tensor, and let's see what happens. And we have to explicitly set this requires squared equals true for now, because it's coming from multi-head attention. And yeah, so layer norm data, and yeah, So we have 12 nodes now and 2 missing links, right? And I just want to trace this thing out, right? I don't really want to write it. Oops. Yes. So when ln, yeah, there it is. So if I run this one more time, yeah, this is exactly what's happening over here. And okay, I don't need it, right? Okay, let's just comment this thing out. And where is X? There it is, the X, and let's just put X over here. 5 visited nodes. What's wrong? There are no data. 5 visited nodes. Nope. I disagree with this. Should not be 5 visited nodes. Layer norm forward. Yeah. So we haven't set this requires correct equals tree, and now if I see I have 12 visited nodes and 2 links are broken. So we need to trace out where exactly the links are broken. I think there is the problem right here. Forward pass. What's wrong here? Out numbers, yeah, there should be OP number of parents or out number parents. 1. Okay, so let's say out number of parents equals 1. We're explicitly setting this. Let's see if this works. Explicitly see the number of parents where the number of parents are 2. A and B, right? Okay, so we need to put check there. If what? Or not B. Fprint F. Parents. Found parents, no. Broken. Or we can do something like this. And similarly, tensor add. Yeah. What's wrong here? So out number of parents. Yeah, that's it. So I think something is wrong here. So out parents 0 equals A and parents 1 equals B. There it is. Yeah, so let's just quickly see if this works, because we found two parents. F print F, something is wrong. F exactly is wrong, so F print and F. Okay. Mm, 9:35. What the heck is wrong? Undefined reference F print NF. Oh man. F pre Woo! Wow! So we've got 15 nodes now, and there's 0 missing links and null gradient. Where actually is the null gradient? So there was something wrong with the subtract method we just figure out, right? So let's just push these changes. Git add dash fixed issues. Okay, so now we have 15 nodes, all of them are visited, no missing link, but we do have one null gradient, and we want to figure out what exactly is wrong there, right? So in case if I run this now, you see we have one null gradient you see we don't have any problem with null gradients, right? And now let me do one more important thing. ln.c. Okay, so now this should be our out. Let's see what it does. 91 visited nodes. It's a huge success. So we are now linking the layer norm with MHA, which is a great success, right? Which is a great success. Perfect, perfect. 91 visited nodes. 77 plus 15 equals 91. We're missing one gradient, which is fine for now, but we have found these nodes, right? And that's perfect. So we've actually resolved the issue with this thing, and I will see you in the next one. We're actually working on few for neural network computational graph. Thank you so much for watching. We'll see you in the next one.